So now we can apply this formula when we're looking at question A. Yet again, our new formula here is E is equal to HF, and H is going to be 6.63 times 10 to the negative 34. And then the frequency in this case is 6.67 times 10 to the 14 hertz. And when I plug that into my calculator, I get 4.42 times 10 to the negative 19. And that's in joules. And as we talked about in the previous video, when we're talking about small energies like this, what we end up using is electron volts. So in this particular case, we're going to divide it by 1.6 times 10 to the negative 19 joules per electron volt. And when I plug that into my calculator, I get an answer of 2.76 electron volts. Now what you'll notice with question B is we don't have a frequency, but we have a wavelength. Now let's think about what we're working with. We're working with light. So we know the speed of light is going to be 3.0 times 10 to the 8 meters per second. And if you remember from last year, we had a formula that was speed is equal to wavelength times frequency. Now we need frequency, so what I'm going to do is bring this over, and I'm going to say speed over wavelength is equal to frequency. So now I can use my equation E is equal to HF, and I can take this right here and I can plug it in. So my new equation is E is equal to H, speed of light, times wavelength. And now I can simply plug in my numbers. So 6.63 times 10 to the negative 34, 3 times 10 to the 8, and wavelength is in nanometers. So I'm going to write 635 times 10 to the negative 9. When I put all this into my calculator, I end up with an answer of 3.13 times 10 to the negative 19 joules. And when I convert it with using 1.6 times 10 to the negative 19 joules per electron volts, I find that I get a final answer of 1.96 electron volts.